Hello. In this video, we are going to be learning how to represent forces with vectors and represent interactions with free body diagrams. And really, forces and interactions are the same things. When you finish, you should be able to identify interactions with objects, represent these interactions with vectors, and label the vectors properly using double subscript notation. To show you this, I'm going to just walk through a couple of different scenarios that point out different features of drawing free body diagrams to represent interactions. And so in this one, we're going to draw a free body diagram to represent the interactions with, which is the same thing as saying the forces on this little dragon, which is sitting on the table. And the first thing that I want to do is to list the things that are interacting with the dragon. If we're going to draw those and represent those, we better have a good list of them. So, things interacting with the dragon. Well, the table's clearly interacting with the dragon. They're even in contact. A second thing interacting with the dragon is an interaction with the earth. The earth pulls down on the dragon. It's actually what gives the dragon its weight. So another object interacting with the dragon is the earth. And again, that provides the weight for the dragon, which is a force. Some of you might think of weight as the same thing as gravity, because it is. All right. Those are the two things that are interacting with the dragon. So now we're going to draw a little dot here, because a free body diagram, the word free means we're going to extract it from its surroundings and just draw the object. And we don't want to get very fancy, so instead of trying to redraw the whole dragon, we're just going to draw a dot to represent that. And by the way, the AP exam will expect you to draw your free body diagrams with dots also. All right, so now we're going to use vectors to represent these interactions. So let's start with the interaction between the table and the dragon. That acts upward on the dragon. And we give that interaction a special name, we call that the normal force or the normal interaction. Normal interactions are between surfaces and objects contacting the surface. And so to label this interaction, I'm going to give it a big N for normal force, and then a double subscript to show the two things interacting. Table on dragon. Normal force table on dragon. Now another thing interacting with the dragon is the earth. And the earth, by way of gravity, pulls down on the dragon. And so we're going to call this the weight of the dragon, which is the earth interacting with the dragon. Again, the double subscripts show us what two objects are interacting. Now, I've attempted to draw these two vectors the same length, not because they are the same interaction. They're most clearly not. But we don't know how to compare the sizes of interactions yet. All we know how to do is we know, for example, in an interaction, the force of one object on the other is the same as the other object on the one object. But if we have two different interactions, we don't know how to compare their size. So for now, we're going to draw the vectors the same length. Eventually, we'll figure out how to compare sizes of interactions. And then, for example, if this one was bigger than this one, we would draw the vector longer. But for now, we're going to draw them the same length. Now let's do another example. Now this example, we're going to look at the exact same scenario. We don't want to overload your brain with too much. But this time, we're going to do a free body diagram for the table, not for the dragon. So again, let's go through and list the things interacting with the table. First thing interacting with the table is, of course, our dragon. A second thing interacting with the table is the earth. After all, the table has weight. Okay, and this again, earth, is another word for the interaction between the earth and the table is gravity or weight. But I want you to realize that we care about both of those things, the object that's interacting and the name we give it. And let's put, and then a third thing interacting with the table is the floor. Now I've tried to use different words here so that our subscripts don't overlap in what letter they are. So let's go ahead and put these on here. So let's put the earth, because the earth pulls down. So this is going to be the weight of the table, which is the earth pulling down on the table. But another thing acting downward on the table is the dragon. And that's going to be, we're going to use the capital letter F for just a generic force, doesn't have a special name. And that's going to be the dragon interacting with the table. And then we have the floor, and the floor acts upward on the table. The interaction between the floor and the table pushes the table in the upward direction. I'm not saying it moves the table, but it pushes upward on the table. And that, again, is a big surface with an object on it. Call that a normal force or a normal interaction, and that's, again, between the floor and the table. So there's our free body diagram for the table. Now, this vector right here represents the interaction between the dragon and the table. This vector here we know would be the exact same size as table on dragon because they're the same interaction. Table on dragon, dragon on table. That's the same interaction. So we know those would be the two same size. We would draw the same size vectors. But of course, they're on different objects, so we don't need to worry about that right now. Let's go on to a third example. A third example, I'm going to have a person pulling a sled up the hill. And again, I'm going to make a list of things interacting with the sled. So we're going to focus here on the sled. So one thing is the rope. Right? The rope is interacting with the sled. The second thing that's interacting with the sled is the ground. I know there's snow there, but let's just call it the ground. And the reason for that, by the way, is sled also starts with S. And if we're going to do a free body diagram with subscripts, we don't want two S letters. And then, of course, the sled has some weight, so we know the earth is interacting with the sled. All right, let's go ahead and add some vectors. Do the free body diagram. So here's our dot. All right, so the first vector I'm going to draw in here is the interaction between the rope and the sled. And we give that a special name. Anytime you have an interaction between like an object, like a thing like a chain or rope, something flexible, we call that tension. So this is tension between the rope and the sled. These are, again, the two things interacting, tension, rope on sled. All right, now we're going to do the interaction between the ground and the sled. Now the ground is at an angle like this, and the interaction between the surface, which is the ground, and the object acts perpendicular to the surface, and we call that a normal force. And so if I imagine the ground being here, the normal force will act perpendicular to the ground like that, and I'm going to label that normal force ground on sled. All right, we also, of course, the earth is acting on the sled. The earth acts straight down toward the middle of the earth, always. And so we're going to draw that vector like that, straight down to the middle of the earth. And again, we label that weight, which is the earth interacting with the sled. And lastly, let's put a little friction between the sled and the snow. Sure, snow is slippery, but it's not infinitely slippery. So let's put a little friction. Now you might say, well, you don't have another thing. Well, friction is between the ground and the sled, so we already listed that object. The ground actually has two interactions, a normal interaction, perpendicular, and then friction acts backwards like that, kind of against the sliding of the sled up the hill. And we're going to label that with a kind of a scripty kind of F, and this is going to be, again, the ground on the sled. And those are the four interactions with the sled. 3 different objects exerting 4 different interactions. All right, that is the end of the video, and I hope you accomplished our goals about learning how to represent interactions with vectors and interactions on objects with free body diagrams.